Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, it is time to continue further with Mathematics class 11th, and yes, we are dealing with the chapter Binomial Theorem, that is chapter number 8. Today is the turn of exercise 8.2 and let's begin with the first question over here. We are asked to find the coefficient of x power 5 in x plus 3 power 8. Now how do we go about finding this? Let's take a look at this question, x power 5 in x plus 3 power 8. The first thing that we are supposed to do is, can we write the general term of this x plus 3 power 8? Yes, maybe. That is something which is possible. So, we have x plus 3 power 8 and in this the general term is tr plus 1. General term is tr plus 1, which is equal to what? This is equal to 8cr, okay. First term, that is x power 8 minus r, and the second term 3 power r. This is what I have. This is the general term of this expression, right? Once you are through with this general term, then next thing that is required is you are supposed to find the coefficient of x power 5, okay. So for x power 5, we can say that this power 8 minus r should be equal to this 5, yes or no? And on the basis of this should be equal to this 5, and on the basis of this you can say that r is equal to 3. The important thing is r should be integer and it should lie from 0 to 8. R should lie from 0 to 8. So that term exists, right? So r is an integer, yes. R lies from 0 to 8, yes. So this value of r equals 3 is okay. Once you are okay with this, therefore, coefficient of x power 5 is equal to what? That can be found very easily. Coefficient of x power 5 is 8cr, that is 8c3 times, this is x power 5, we are not supposed to worry about the variable part, we are supposed to worry about these constants over here. This is 3 power 3. That's the answer. Okay, let's simplify this as well. 8c3 is equal to what? This will be 8, 7, 6 over 3, 2, 1 times 3 power 3 is 27. 3 times 2 is 6, which gets cancelled over here. And this is 56 times 27. Let's multiply them together and get the answer. 7 times 6 is 42, 4 carries, 35 and 39 and 12 is 51, 1, 5 carry to 10 and 5, 15, 1, 5, 1, 2 is my product, and that's the answer for this question over here. Let us discuss this next question over here. What does the question say? Find the coefficient of a power 5, b power 7 in this a minus 2b whole power 12. Now how do we go about solving this one? Let's take a look at this question. So for a minus 2b whole power 12, the first thing that will require, once again, the first thing that will require is the general term. So can you help me write the general term of this expression? The general term will be the tr plus 1 term, right? What is the tr plus 1 term? Tr plus 1 term will be 12cr. This will be 12 CR. First term in the binomial a minus 2b is a power 12 minus r, and the second term is minus 2b, and that is power r over here, right? Next, can we simplify this further? This is 12 CR minus 2 power r is there, and then you have a power 12 minus r, b power r, okay? What else? Since you are asked the coefficient of a power 5, b power 7, can you help me with that? So for a power 5, b power 7, this term, we should check the powers of a and check the powers of b, right? So for power of a, 12 minus r should be equal to 5, and this r should be equal to 7. Can you observe that here you will get r equals 7 and r equals 7. So r is equal to 7 is the required term, right? For the required term, you'll have r equal to 7. Therefore, coefficient of, the coefficient of which term? A power 5, b power 7 is equal to, you're supposed to take r equals to 7, okay? This will be 12 c 7 times minus 2 power 7. Is that okay? Minus 2 power 7. Rest terms are this only, a power 5, b power 7, and this is the coefficient of this term. 12c7 times minus 2 power 7. And can you help me find this value? 12c7 times minus 2 power 7. Do we have to calculate this? Okay, let's, yes, we'll have to calculate this further. And let's find this value. 12c7 is same as 12c5. So this will be 12 times 11 times 10 times 9 times 8 over 5, 4, 3, 2, 1. And this is minus 2 power 7, which will be minus 1 is extra, okay, and you'll have a 2 power 7 in the numerator. So let's write 2 power 7 as well, right? This is something that we'll have in the numerator. Okay, do we get any terms being cancelled over here? Yes, 4 times 3 is 12, that gets cancelled. Then you have 5 times 2 is 10, that also gets cancelled from the numerator and denominator. What remains is this 11 into 9, which is 99, and 8 is 2 power 3, this is 2 power 7. They will combinedly be 2 power 10, right? So what you get is minus 99 times 2 power 10. Now what is 2 power 10? You should remember 2 power 10 is 1024. Right. And what is 99 times something? So for finding 99 times something, what I can do is I can multiply 1024 by 100 and I can subtract 1024, right? This is what I can do. Is that okay? 100 minus 1 is 99. So multiply 1024 by 100 and subtract 1 times 1024. So what you'll get is 102400 minus 1024. This is what you're supposed to do. This is what you're supposed to do, right? So once you do this, what you'll get is this minus times what you have is 76 at the end, okay, and 24 will be 23 actually. 3 minus 0 is 3, and this will be 2 minus 1 is 1. This will be 101376 with a minus over here. And yes, that is my answer for this question, as you can see over here. So up to here is the use of binomial, and after this you just have to calculate the values. So calculation may take some amount of time, but other than that, it's pretty simple to solve this question. Is that all? Yes, that's all in this question. Let's move on to the next one after this. What does the question say? Write the general term in the expansion of x square minus y whole power 6. We are supposed to write the general term. That's the only thing that we are supposed to do. Let's do that. General term of this x square minus y power 6 will be the tr plus 1 term. Tr plus 1 is the general term. What is that? This is 6cr x square power 6 minus r minus y power r. This is the general term of this expansion. So can I simplify it further? 6cr, this is minus 1 power r times x power 12 minus 2r, okay, times y power r. That's the general term of this expansion over here. Is that over? Yes, that's all that we have to find in this question over here. Let's move on to the next question after this. What does the question say? We say write the general term in the expansion of this x square minus yx power 12, where x is not equal to 0. We are supposed to write the general term in this question. Let's write the general term. So for the general term, we are supposed to find actually the tr plus 1 term. That is 12cr. That's 12cr times first term. That is x square power 12 minus r times minus yx power r. This is what you get. Right? This is what you get. This is the general term. Okay, and let's simplify this further. This is 12cr, which is okay. Minus 1 power r will come over here, and you'll get x power 2 times 12 is 24 minus 2r. Okay, what you have remaining is y power r, x power r. These similar terms, x will also, the powers will also get added over here since they are in multiplication. So you'll get this term, x power 24 minus 2r plus r is 24 minus r, y power r. This is what you have, right? That is the final answer for this question over here. Let's move on to the next one after this. What does the next question say? Find the fourth term in the expansion of this x minus 2y whole power 12. Now how do we go about finding the fourth term in the expansion of this? Let's take a look at this. So we know that tr plus 1, that's the general term, is equal to 12cr, okay, x power 12 minus r minus 2y power r. This is something that's there. tr plus 1 is 12cr x power 12 minus r minus 2y power r. Once you're through with this, then you can say that fourth term implies that r equals 3. Therefore, T4 will be equal to T 3 plus 1, which is equal to what? Which is equal to 12 C3. The value of r will be simply 3. And after that, what you'll have is x power 12 minus 3 minus 2y power 3. This is what you have, right? What next? What next? This is 12C3. 12C3 can be simplified further. Yes, fourth term is supposed to be found. 12C3. Let's simplify this. This is 12, 11, 10 over 3, 2, 1 times x power 9 times minus 2 power 3. Now, minus of power 3 will be a single minus will remain, and 2 power 3 is 8. So, this is minus 8. This is y power 3. This is what you have. And do we get any terms getting cancelled? Yes, 3 times 2 is 6. 6 times 2 is 12. And what you get is 8 times 2 is 16. 16 times 11 is 176. So, this is minus 176. And there is a 10 x power 9 y power 3. That is my answer for this question over here. As you can clearly see, find the fourth term on this expansion. That's the final answer for this question. Let's move on to the next one. The next one says, find the 13th term in the expansion of 9x minus 1 upon 3 root x power 18, where x is not equal to 0. We're supposed to find the 13th term. So let's take a look at the 13th term. T13 will be actually T12 plus 1. Right? This will be T12 plus 1, which is 18C12, 9x power difference of these two, that is 18 minus 12, and the second term of the binomial is 3 root x minus 1 upon 3 root x power 12. This is what you have. NCR, first term power n minus r, second term power r. That's what you have, right? That's the general term for this expansion. And can we simplify this further? Yes, we can simplify this further to get something easier. But as you may see over here, 18C12 is pretty big. But let's see what happens over here is 18C12. Let's try to find that. 18C12 is same as 18C6, right? Okay. So what I'll have is 18, 17, 16, 18C6, 6, 5, 4, 3, 2, 1. You'll have 15, 14 and 13, right? 6 terms here, 6 terms here. Then you have 9x power 6. So this is 9 power 6 times x power 6. Then you have minus 1 power 12, which is plus 1. Okay. Then you have 3 power 12 in the denominator. Okay. This is 3 power 12. Okay. That's interesting. 3 power 12 and 9 power 6 are same, right? They will get cancelled. Under root of x power 12. This will be x power 12 by 2, which is x power 6. Okay. That will also get cancelled. We just have to find this expression. Okay. Let's do it. Let's do it. So, what do I have over here is 6 times 3 is 18. This gets cancelled. Then you have a 4 and a 2. 4 times 2 is 8, which gets cancelled over here. Then you have 5 times 3, which is 15. Okay, so what remains? What remains is 17 remains. Okay, 2 times 3 remains, which is 6. Let's call this 6. 14 remains and 13 remains. This is what we have remaining over here. What else? 9 power 6, 3 power 12 are same. Let me write them. 9 power 6 and this is also 9 power 6. This is x power 6 over this is again x power 6. These terms will get cancelled and you will get a 1 in product. So we are only supposed to find this product over here. How do we go about finding this? Let's multiply them together. This is 15 plus 2. This is 15 minus 2. Right or not? Yes. So 15 plus 2, 15 minus 2 can be multiplied very easily. 17 and 13. The product is 225 minus 4, which is 221. The product of these two. And what is 14 times 6? Now that's simple. 14 times 6 is 84. Yes, this is 84. And 84 times 221 is what we are supposed to find now. Let's multiply them together. 221 times 84. Okay. And how do we multiply them together? Let's multiply them. This is 4 times 1 is 4. 4 times 2 is 8. 8 times 1 is also 8. 8 times 8 plus 8 is 16. 6, 1 carry. Okay, 4 times 2 is 8, 8 times 2 is 16, 16 plus 8 is 24, plus 1 is 25, 5 and 2 carry, 8 times 2 is 16, 16 plus 0 is 16, 16 plus 2 is 18, this is what you get. 18564 is what I get, this is 18564, this should be my answer for this question over here. Is that all? Yes, that's all in this question as you can clearly see behind me. Let's move on to the next question after this. The next question says, find the middle terms in the expansion of this. So 3 minus x cube upon 6 whole power 7. We're supposed to find the middle terms. Now if this expression, this number over here is odd, the number of terms, this number here is 7, the number of terms will be 8, which is even. Okay. In case of even number of terms, you'll have two middle terms. Okay. N equals 7 implies n plus 1 is equal to 8 terms. This further implies that there will be two middle terms. Which are the two middle terms? Since there are total 8 terms, the two middle terms will be 4th and 5th. How did you get this 4th? Basically n plus 1 by 2 is what you do. This is n by 2, n plus 1, just a minute. N is 7, right? So we are just supposed to write, not this, just supposed to write n plus 1 by 2 is what I'm interested in, right? This is one of the middle terms. And the other is n plus 1 by 2 plus 1th middle term. Right? These are the two middle terms in this case. And can we find the values of those middle terms? Yes. We are supposed to find the middle terms, right? So T4 is the one. T4 is what we are asked to find. T4 will be T3 plus 1. Let's try to find T4 first. That's the first middle term. T3 plus 1 would imply this is 7C3 times, first term of the binomial is 3, power 7 minus 3 times minus x cube upon 6. Minus x cube over 6. This is minus x cube over 6 power 3, as you may observe. This is T4 for us, right? And what is T5? Let's write T5 as well. T5 is T4 plus 1, which will be equal to 7C4. 7C4 times, in this binomial the first term is 3, so 3 will be raised to the power 7 minus 4 times, next term in this binomial is minus x cube by 6 raised to power 4 is what you get, right? These are the two middle terms. Now the only thing that remains is to calculate and find these middle terms. Let's do that. This simplifies to 7C3 is equal to 3, 2, 1 over here. Yes. This is 3 power 4, which is simple. And what is this? This is minus, yes, minus remains, minus of x power 3 is x power 9. In the denominator, you have 6 power 3. Okay, 6 power 3 is 3 power 3 times 2 power 3. Okay. We can observe that 3 times 2 is 6, that will get cancelled. And what else? 7 times 5 is 35. 3 power 4 and 6 power 3 will have something remaining. This is 3 power 3 will get cancelled. This will be a 3 remaining. And this will be a 2 power 3 remaining, right? 3 power 3 will get cancelled. This will be 2 power 3. Is 2 power 3 getting cancelled? No. What you get is 35 times 3. 35 times 3 is 105. You have a minus 105 over 2 power 3 is 8. X power 9 also remains. So this is the middle term. This is one of the middle terms, right? What about the next one? This is 7C4. Let's try to calculate this also. 7C4 is 7, 6, 5 over 3, 2, 1. Since 7C4 is same as 7C3, this is what you get. 3 power 7 minus 4 is 3 power 3. Okay. Minus power 4 will be plus, and x power 3 will be x power 3 power 4 will be 12. Okay. 6 power 4 will be in the denominator. Okay. So what next? 3 times 2 is 6. It gets cancelled. 3 power 3, and here you'll have 3 power 4, 2 power 4. So 2 power 4 will remain as it is, and 3 power 4 of 3 power 4, 3 power 3 will get cancelled, only 3 will remain. So in the numerator you get 35, in the denominator you get 16 times 3, which is 48 x power 12. This is the other middle term. There are two middle terms, and these are the two middle terms that we are looking to find. Is that all? Yes, that's all in this question over here. Let us discuss this next question in front of us. The question says find the middle terms in the expansions of this. Okay, let's try to find a middle term. X power 3 plus x by 3 plus 9y whole power 10 implies then n equals 10. Okay, if n equals 10, you'll have total 11 terms. And 11 terms implies that you'll have one middle term. What's that middle term? That's simply 11 plus 1 by 2, that is 6th term will be the middle term. Do you have any formula for this? Yes, you have formula that if n equals to 10, so you are supposed to find n by 2 plus 1th term. This is your middle term, right? This is your middle term in this. And let's try to find this value, 6th term. T6 is actually T5 plus 1, which will be equal to 10C5. And then observe, in the binomial you have first term as x by 3. So x by 3 will be raised to power 10 minus 5. And 9y will be raised to power 5. So x by 3 raised to power 10 minus 5, 9y raised to power 5 is what you get. Right, this is what you get. What next? This is 10C5. Okay, let's try to simplify this. This is 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. This is what you get, right? What next? This is x power 5, okay, 3 power 5, what do you get in the denominator? This is 9 power 5 over here, y power 5 with that, right? This is what you have. Let's multiply them together. And what do I observe over here is 3 power 5, 9 power 5, you will get a 3 power 5 extra in the numerator. 3 times 2 is 6, let's get rid of this. And 4 times 2 is this. 5 times 2 is this, okay? This is what you have. So denominator will be total 1, and in the numerator you will have 2, 9, 2, 7 and 3 power 5. Okay, let's multiply them together. What is this? This is 9 times 7 is 63. 63 times 2 is 126. 126 times 2 is what? 126 and times 2 is 252. 252. The product over here is 252. Then you have 3 power 5. What's 3 power 5 equal to? Now 3 power 1 is 3, 3 power 2 is 9, 3 power 3 is 27, 3 power 4 is 81, 3 power 5 is 243. So you get 2, 4, 3 in the product. And then you have x power 5, y power 5 as well. Okay, pretty interesting. Can we multiply these two together? Yes, they are two 3-digit numbers. And 252, 243. Let's multiply them together. 3 times 2 is 6. Okay, are we multiplying them in a single line? Yes. Okay, next 3 times 5 is 5 times 3 is 15. 4 times 2 is 8. 15 plus 8 is 23. 3 and you carry on a 2. Okay. Then you have 3 times 2 is 6. 2 times 2 is 4. 4 plus 6 is 10 and 5 times 4 is 20. 20 plus 10 is 30. 32. Okay, 2 and you carry a 3. Then you have 4 times 2 is 8, 5 times 2 is 10, 10 plus 8 is 18, plus 3 is 21, 1 and you carry a 2. Okay, and then you have 2 times 2 is 4, 5, 6. This is what you get, 6, 1, 2, 3, 6, x power 5, y power 5. This is my final answer for this question over here. 6, 1, 2, 3, 6 times x power 5, y power 5 is what you get over here. Is that all? Yes, that's the complete solution of this 8th question. Let's move on to the next one after this. In the expansion of 1 plus a whole power m plus n, prove that coefficients of a power m and a power n are equal. We're supposed to prove this. Okay. Let's try to solve this one. What do we have? We have 1 plus a whole power m plus n. Okay, this is what we have. And can you help me write the general term in this? This is tr plus 1, which is m plus n cr 1 power something, m plus n minus r times a power r. This will be simplified as m plus n cr. This is gone, a power r. This is what you get, right? This is what you get. So coefficient of a power m. For coefficient of a power m, what will be required is, will be required to find this r. The value of r will be simply m. Coefficient of a power m will be equal to what? This will be equal to m plus n cm. Is that simple? Yes. What about coefficient of a power n? For that, will require r equals, since you want a power n will imply r equals n, and the coefficient will be m plus n cr, which is n over here. This is what you get. Is that okay? Yes. And we have to prove that the coefficients of a power m and a power n are equal. Let's apply one result on this. M plus n cn is also equal to m plus n c this minus this, which is m plus n minus n. What have we used over there? We have used that NCR is equal to NC n minus r. Is that okay? Yes. And this further simplifies to m plus n c m. Okay. And since 1 and 2 can be observed to be same, therefore, hence you can say that the coefficients are same simply using 1 and 2. Is that all? Yes, that's all in this question over here. That's a complete proof. Yes. Let's move on to the next one. The next question says the coefficients of the r minus 1th, rth and r plus 1th terms in the expansion of x plus 1 whole power n are in the ratio 1:3:5. Find n and r. Okay, there's a condition which is given, right? Very interesting question. Okay, such kind of question have been asked in the examination over and over again. Not only the board examination, in the JEE examination as well. Especially JEE main people keep on asking such questions, right? JEE advanced people, okay, they have moved beyond this, right? They used to ask such questions at one particular point of time. They may ask again in some complicated form, but such simple questions, yeah. There's bit of calculation, except for that there's no concept, there's no difficult concept involved over there. So this is a JEE main type of question as well. The coefficients of the r minus 1th, rth and r plus 1th terms in the expansion of x plus 1 whole power n are in the ratio this. So we are concerned with x plus 1 whole power n, and in this we are concerned with tr plus 1 first of all. Okay, general term will be tr plus 1, but it is given that, let's focus on what is given for a minute. It is given that the coefficients of r minus 1th, rth and r plus 1th terms are in some particular ratio. Okay, let's try to find the coefficient first. Yes, so tr plus 1 will be equal to ncr x power n minus r and 1 power r. 1 power r is simple, that's 1 only, right? So coefficient of r plus 1th term is simply ncr. Can you observe that? Yes. The ratio coefficients of r minus 1th is to coefficient of rth is to coefficient of r plus 1th. This ratio is given to be 1:3:5. Now what does this imply? This implies that this coefficient of r plus 1th term is NCR, which is pretty simple. Okay, before that you'll have NC, one term before this you'll have NCR minus 1, and one term before that you'll have NCR minus 2. Is that okay? Yes, can you observe that easily? Once you observe that, this is 1:3:5. Okay, this is 1:3:5. And now, how many variables do you think are there? There are two unknowns, n and r. There are two unknowns, that is n and r. And how many equations do you think have been given? If you observe, you can compare these two and these two. Pick up these two ratios. Let's pick them up. So the first condition, the first equation will be NCR minus 2 over NCR minus 1 is equal to 1/3. Yes. Another condition would be related to NCR minus 1 upon NCR, which is equal to 3/5. Do you observe that? Yes. Ratio of first two terms, ratio of last two terms. Yes. And we have picked up those two equations in terms of the two unknowns n and r. Let's find the values of n and r after this. What will this simplify into? This is n factorial upon r minus 2 factorial. Okay. Let's do one thing. Let's write it in the next line since we have less space remaining over here. Okay. Let's write it in the next line. So this implies that n factorial over r minus 2 factorial of the numerator times difference of the two, n minus r plus 2 actually. This will simplify into this, right? That's the first term. And the denominator will look like n factorial. Denominator will go at the top. This is r minus 1 factorial, and the difference of these two, that is n minus r minus 1, which will be n minus r plus 1 factorial is equal to 1/3. Is that okay? Yes. We see that n factorial will get cancelled. Yes. R minus 1 and R minus 2. Now R minus 2 is smaller than this. 1 unit is smaller than this. So there's a R minus 2 factorial hidden in this. This will be R minus 1 times R minus 2 factorial. Yes. So this and this will get cancelled, r minus 1 will remain. N factorial will get cancelled, yes. What about the other term? This and this are just 1 unit apart. This is smaller, this is bigger, this will be bigger, therefore n minus r plus 2 will remain over here, yes. And from here you can observe that r minus 1 upon n minus r plus 2 is equal to 1 upon 3. Once you know this much, you can simplify this. This is 3r minus 3 is equal to n minus r plus 2, or you can say that 4r is equal to n plus 5. This is the first equation which we were targeting. From the first condition we get the first equation. Let's use the second condition to get the second equation. How do we get that? This simplifies to what? This simplifies to, let's take a look at this. This is n factorial upon r minus 1 factorial, okay, and difference of these will be n minus r plus 1 factorial. The denominator is NCR, which is n factorial, over r factorial n minus r factorial is equal to 3 over 5. This is what I get. Let's cancel a few terms over here. I see that n factorial will go. R factorial and r minus 1 factorial will leave out the r at the numerator, okay. And you have this and this is a bigger term, this is a bigger term, so n minus r plus 1 will remain over here. Observe. What you get is r upon n minus r plus 1 is equal to 3 upon 5. Let's cross multiply. 5r is equal to 3n minus 3r plus 1. Do you observe that? 3n minus 3r plus 3, right? And let's bring that 3r over here. We get 8r is equal to 3n plus 3. That's the other equation. So the first equation and the second equation is what we get. Can we solve these two equations further to get the values of r and n? Yes, very easily. This is, let's call this first equation, let's call this the second equation, and let's solve these two equations over here. Right? There's plenty of space over here for us to solve these equations. Let's do that. 4r and 8r. Okay, so let's multiply that first equation by 2 and they'll be equal, right? So 2n plus 10 will be equal to right hand side, that is 3n plus 3. What have we done? We have multiplied the first equation by 2. The left hand side will become same and the right hand side will also be same. 2n plus 10 will be equal to this. So from here n will be equal to 7. Okay, the value of n that we get is 7. What about the value of r? The value of r can be obtained from the first equation. Therefore 4r is equal to 7 plus 5, which is 12, implies r equals 3. This is what I get. So the value of n and r were asked. N is 7, r is 3. That's the answer for this question over here. Is that all? Yes, that's all in this question, as you can clearly see behind me. Right? Calculations, as I said, calculations are there, but other than that, concepts, from the point of view of concepts, there's very little concept involved over here. That's it. We just have to write the general term, write the ratios, and from ratios we form two equations. The forming of equations will take some amount of time, but other than that, it's all very simple. Is that okay? Yes, that's okay. Okay. Do we need anything else in this? No. That's the final answer for this question over here. Let's move on to the next question after this. The question says, prove that the coefficient of x power n in the expansion of this is twice the coefficient of x power n in the expansion of this. Twice the coefficient of x power n in the expansion of this. How do we do that? Coefficient of x power n in the expansion of this. 1 plus x power 2n. The general term tr plus 1 is 2n cr x power r. 1 power 2n minus 1, simple, right? Okay, so coefficient of x power n is equal to what? For x power n, r will be equal to n, as you can observe over here. X power n will imply that r equals to n, and this coefficient will be 2n cn. Is that simple? Yes. What next? Twice the coefficient of x power n in the expansion of this. Let's try to write the expansion of this as well. For 1 plus x power 2n minus 1, you have tr plus 1 as 2n minus 1 cr times x power r. Once again, you have this. So coefficient of x power n, coefficient of x power n, for x power n, you'll have r power r equal to n. This will imply this is 2n minus 1 c n. Is that okay? Yes. And what are we supposed to prove in this one? We're supposed to prove that coefficient of x power n in this is twice the coefficient of n. To prove 2n is equal to twice of this value. This value is 2n minus 1 cn over here. Yes. How can you go about proving this one? Let's take a look at this question. So, can we begin with the LHS or should we begin with the RHS? We can begin anywhere. Let's try to, this is a complicated version, right? Let's begin with this one. So, proof. RHS is equal to 2 times 2n minus 1 Cn. Can I write it? Simplified. In terms of factorial form, yes, this is 2n minus 1 factorial upon n factorial times the difference of these two. Difference of these two will be 2n minus 1 minus n, which is n minus 1 factorial. Now, if I want to reach over here, what I'll need is 2n factorial upon n factorial, n factorial. There's already n factorial, there's n minus 1 factorial. Let's multiply with the n in the numerator and n in the denominator. Okay. So, what you have is 2n. 2n is one thing. 2n minus 1 factorial is already there. Okay. Then you have n factorial and you have n minus 1 factorial times n, which will be n minus 1. Let's write it combined, and what you have over here is, observe carefully, n minus 1 factorial, basically 3 factorial times 4 will actually be 4 factorial, right? So n minus 1 factorial times n is actually n factorial, not n plus 1 factorial, this is n factorial, right? Keep that in mind. N minus 1 factorial times this. So n minus 1 factorial times n will be n factorial, right? And similarly 2n minus 1 factorial times 2n, the next term will actually be 2n factorial. This is n factorial, this is n factorial. And do you observe that this is equal to the LHS? Yes or no? Do you observe that this is equal to the LHS? Yes, this is equal to the LHS. And that's a complete proof for this one. That's a proof of this one. Yes. That's all that you have in this question. Is that all? Yes. Let's talk about this question next. Find a positive value of m for which the coefficient of x power 2 in the expansion of this is 6. Okay. Positive value of m, that is what is being asked. M greater than 0, m question mark. Okay. Coefficient of x square in the expansion of this is 6. So we are interested in 1 plus x power m. The coefficient of x square. Let's write the general term for this. Tr plus 1 will be equal to mcr 1 power m minus r x power r. Okay. For coefficient of x square, we'll have r equals 2. Yes, we'll have to apply r is equal to 2 because x power r is equal to x square. Therefore, r will be 2. You'll get mc2. What you get is mc2. Okay. And it is given that mc2 is equal to 6. Okay. Coefficient of x square in the expansion of this is 6. We have to find a positive value of m. Can we find a positive value of m? Yes. Okay. So for m c2 to be defined, m should be a positive integer, and let's try some integers over here. This is actually simplified into m times m minus 1 over 2 times 1. Yes or no? mc2 will be this. This will be equal to 6. Let's multiply them. This is m square minus m is equal to 12. Or you can say that m square minus m minus 12 is equal to 0. Can I factorize using splitting the middle term? Yes. 12 can be written as minus 4 times 3. This is m square minus 4m plus 3m minus 12 is equal to 0. The factors can be found very easily. M will come out common. What will remain is m minus 4. Okay. From here 3 will come out common, plus 3 will come out common, and what will remain is m minus 4. Right? This is what you get. This is a factorization. This is equal to 0. Therefore, m will be equal to 4 or m equals minus 3. Obviously, minus 3 is rejected. M is equal to 4 is the answer for this question over here. Is that the answer? Yes, that's the final answer for this question over here. That's all. And with this, we come to the conclusion of this exercise 8.2 based on Binomial Theorem, chapter number 8 from NCERT class 11th. If you have enjoyed this video, please like and share this video with your friends, and also subscribe to the channel of Vyas Edification if you have not yet done it. For latest updates related to all competitive exams, you can subscribe Vyas Edification and remain in touch with us. Do attend the live session which is associated with this chapter over here. Right? Till the next session, all the best.